Okay, here's the fifth question you sent me. You have it labeled as 6. So anyway, I'll call it the fifth question. So you're given the second derivative of a function. That's your second derivative here. And I'm assuming here they want you to recover the function. And I'm assuming they want you to find the value of that phi is equal to 3. Even if they don't, I think with everything I'll do here, you'll be able to extrapolate enough information to do whatever they want you to do. So recovering a function. So let's have a look. They've given us the second derivative. So I want to basically get down to a function y equals to. So how do I get from the second derivative to the derivative? Well, if I integrate the second derivative, I'll get my first derivative. And remember now, you have the c as well there. So before I go any further, I'll have to figure out what c is. So then I'll have my derivative. And if I integrate that, I'll get y. And I'll have my c, so I'll have to find out what my c is. And once I do that, I'll have the function y is equal to x and blah, 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 other stuff with x's as well. I don't know what will come out. The last step will be to find y of 3. I'll be just subbing 3 in for my x. So first steps first. If we have our second derivative and I want my first derivative, I have to integrate my second derivative. So I just integrate it piece by piece. So integrating 5 cos of x. Now remember, we don't care about the 5, that can be outside, but it's the cos of x we're interested in. So the integral of cos of x is sine x. So 5 sine x. Now, integrating e to the power of minus x. Remember, e to the power of minus x is e to the power of minus 1x. So look up your e to the ax when we're integrating it. That's what we're integrating. So 1 over a, so it'll be plus 1 over minus 1, e to the power of minus x. All right, plus c. Now we'll just rewrite that little, 5 sine of x. Now 1 over minus 1 is minus 1. So minus 1 times e to the power minus x plus c. So that's my derivative dy dx. Okay, now they've told me here, and I wrote this incorrectly up here. That's wrong. Actually, it's all wrong. They're saying when dy dx in your question is 0, so when dy dx of 0, so when x is 0, the whole derivative should be equal to minus 4. All right. So they're asking me to sub 0 in for x. So it's 5 times the sine of 0 minus e times minus 0 plus c, and it should all be equal to negative 4. So the sine of 0, let's look that up. Sine of 0, I'm always cautious because I think I remember them, but then I make a mistake. So sine of 0 is 0, so 5 times 0 is 0, that's grand. Anything to the power of 0 is 1, plus c is negative 4. So c is negative 4 plus 1, so c is negative 3. Okay, so now I have the first value for my c. So dy dx is equal to, we said it's 5 sine x minus e to the power minus x plus c, and my c is minus 3. Okay, so now I've got my derivative. I want to go up again to find y. So I want to get y, and I do that by integrating my derivative. So 5 sine of x minus e to the power of minus x minus 3. And do you know what I keep forgetting to put this in? It's a very, very bad habit. If I'm integrating a function with x in it, I have to put in my dx, and I keep forgetting to do that. And if you forget to do that in a substitution question, you end up ruining your mind trying to find out where you went wrong. So much so that my 6th years commonly scream at me dx when I forget to put it in. In fact, so much so it actually went up on a 6th year graduation poster once, the words plus c. Anyway, anecdotes aside, we integrate this, so it's an easy enough integral. So the integral of 5 sine x, so the 5 is multiplying, so I don't really care about that. It can sit outside or whatever. But the integral of sine x is minus cos x. So it'll be minus 5 cos x. Now we spoke about this integral already. E to the power minus x, we did that already, and the integral of that is 1 over minus 1 e to the power minus x. The integral of minus 3 is going to be minus 3x. Then I'm going to have my plus c. We tidy it up a little bit. Minus 5 cos x. Now 1 over minus 1 is minus 1, so minus minus 1 is plus 1. So plus 1 e to the power of minus x minus 3x plus c. All right, now look at the information that they gave us. So if we have the derivative now, if we have a function in y, and I let x equals to 0, the whole function should equal to minus 1. Okay, So they're saying let x equals to 0. So minus 5 cos of 0 plus e times minus 0 minus 3 times 0 plus c, then that whole function should equal to, and I've forgotten already what they said, negative 1. Okay, let's double check that. Negative 1, that's correct. Negative 1. Okay, so looking up the cos of 0. Cos of 0 is cos of 0 is 1. So minus 5 times 1 is minus 5. Anything to the power of 0 is 1. 3 times 0 is 0. Plus c equals minus 1. So minus 5 plus 1, minus 4, plus c equals minus 1. Okay, so c is equal to minus 1 plus 4. C is equal to 3. Now, I'm not 100% sure what you're being asked to do in the question, but look, we'll write out our function now. So our final recovered function is y is equal to minus 5 cosine of x plus e to the power of negative x minus 3x plus 3. And from what I can see in the question, what you're being asked to do is to evaluate y of 3. That means substitute in x for 3. Oh, sorry, where did I have it here? Yeah, substitute in x, or 3 for x, 3 for x. So let's do that. And if not, I'm sure you can work out what it was you were supposed to do. So minus 5 times the cos of 3 plus e times negative 3 minus 3 times 3 plus 3. Now, okay, again, you can do it in any mode you want, but as far as I know, that was done in radian mode, I'd imagine. So I'm just going to pause while I input that into the calculator. Okay, so your answer is minus 1, and there's change is 0.00250049, but minus 1. So again, before you do anything, check over my own calculations. Just check if I missed out a negative or I did something stupid. Okay, thank you.